Okay, so I'm going to do the second part of 3.4. I had said that it wasn't just solving exponentials like yesterday. The second part was solving logarithms. So that's today's lesson. So just with your exponential, you had two techniques. You also do on logarithms. And again, that means my equation is going to look something like this. You see how there's an equal sign? And it's a log. So these must be the logarithmic equations. So here is the first technique. That means I have a log on one side of an equal sign. Like this one has a log only on one side, it's not on both. That's what this technique is. It's only a log on one side. And in parentheses, I'm going to tell you what technique I'm going to do with this. What I'm going to use is I'm going to use this inverse definition, where I can go from here to here. That's what I'm going to use in this log on one side. I'm going to use this to solve. It'll make more sense as I start doing problems. I'm just kind of waiting to see when I see you stop writing. So here is the first example. So log base 4 of x plus 3 equals 2. So this is clearly not exponential, it's logarithm. There's an equal sign. I'm supposed to be solving for x. And I'm going to use this technique called log on one side by using the inverse definition, because there's only a log on one side. Well, look at your x is trapped in here. And in exponentials, it's trapped in the exponent position. Now my x is trapped in here. I need to get it out of here. Well, I don't know how to get it out of here. So I'm going to use this definition. I'm going to switch it over to an exponential. So what would the big base be on an exponential from here? 4. So it'd be 4 to the second power equals this. Well, now look at my x is untrapped. So now this just becomes an Algebra 1 problem. Voila. I have either 2 or 3 more examples. And I try to cover every kind of things that you might see on the homework. Here's another one. And it's an equation. It's got an equal sign. And I'm solving for x. Well, he's trapped in this position. I don't know how to get him out. So I'm going to use this technique, log on one side, because there's only a log on one side, and I'm going to use that definition where I do the inverse. The only problem is, I'm going to bring this down for a minute, is that in order to go from here to here, there can be no coefficient in front of log. I can't have one here. It has to look like this before I can change it over. So with this one here, what's in the way? The 4. So I have 2 ways I could do this. What could I do to get rid of the 4? Yes. Move it up to the exponent. That's what I keep doing too. There's actually an easier way that I kept forgetting to do. Dividing. I could divide by 4 and make it a 2. I kept forgetting that. I get the same answer, except that way it takes me a little bit longer. So I'm going to go ahead and I'm going to choose the easier way. I'm going to divide by 4. So then I'm left with this problem. My x is still trapped. I mean, I'm still trying to solve for him, but now I can use that inverse definition. I can go and change it to exponential. Except what is my base here? E. Okay. So now it's e to the second power equals 3 times x. But now my x is untrapped. What do you think I do to solve for x? That's it. That's all you do. To go any further, I'd have to pull out a calculator and have an approximate answer. That's an exact answer. E squared, which is 2.71, squared divided by 3. Whatever it is. I don't know, but there it is. try another problem. Looks like I have 2 more. So another way to look at this thing called log on one side is that, like I have 1, 2, 3 terms. There's one of them that has no log. This I could condense by the product rule down into 1, right? Okay. So that's actually the technique I'm going to do. And because there's no other coefficient besides 1, I can use the product rule, and I'm going to condense it. So it just means x times x minus 7, which is just what I wrote there. I decided not to multiply it quite yet. Again, I'm supposed to be solving for x, but it's trapped. It's trapped here. So maybe the way to untrap it so I have some hope of solving is changing it to the exponential form. So it's 2 to the 3rd power equals all of that. Now I'm going to multiply that all out. Let's see. That would be an 8, and that would be an x squared minus 7. X. What do you think I do from here? What is it looking like it's going to be? Quadratic. And how do I solve quadratics? What do I do? Yeah, I have to have a 0 on one side, right? So I need to move the 8 over. And I want my leading variable with the square positive. So I want him over here, so let's move him over there. And I started to put a plus, so it's supposed to be a minus. That was my mistake. So I'm going to scoot this up a little. And so what do we typically try to do here to solve? We try to factor, right? And so I tried to factor, and I was successful. I put an x in each position. 8 to get a 7 would be at an 8 and a 1, negative 8 and a positive 1 will satisfy that. Then I set each one equal to 0. Now we have something that we have not addressed before. I'm going to bring this down so we can see the whole thing. There it is. Okay. Do you remember when you did homework, I think it was last night, about the domain? What is this value supposed to be? When I first did the definition, what does this place right here have to be? Like, we know the base has to be greater than 0 and it cannot be 1. What is the rules on this? It's in your notes from like 2 or 3 days ago. It's the very first thing I did. In fact, 2 days in a row is the first thing I did. What did I say about this? There's some qualifiers on it. Like my b base has to be greater than 0 and it cannot be 1. Does anybody remember what this is? Has to be greater than 0. I said this has to be greater than 0. In fact, that's how you found the domain. You set this and you put it has to be greater than 0. So you've got to take these two values and plug them back in to see if they both work. So let's put in our positive 8. Is that positive here or greater than 0? I put in 8 in here. Is that greater than 0? Okay, so far that works. Let's try negative 1. I put that in there. Is that greater than 0? It fails. So it's not a solution. It's those extraneous solutions. Sometimes they don't work. I have to go back and test. And that's going to come up again. Here's another problem, very similar to the last one. Okay, I'm solving for x. I can get a log on one side and have just a number over here. They both have the same base. They don't have a coefficient other than 1, so I guess I can start condensing it by using quotient rule. Again, my x is still very trapped. But it's down to a log with a base with something here and a number. I can now go ahead and I can go ahead and use the definition, the inverse definition, and now change this to exponential. So that would be 2 to the third power equals that x plus 2 over x minus 5. So the only thing I can really clean up here is just make that an 8 so I can see the number clearly. Okay, now I got an x in a numerator and in a denominator position. Like what kind of, not just algebra, what should I do algebra-wise? I mean, I need to probably get this out of the denominator, so what could I do? Multiply it like on each side, right? And when I multiply this on each side, doesn't that cancel out over here? Right? Isn't that kind of what it looks like? At least I have no more fractions. And the x's are all up on my blue lines now. So now if I multiply that, I just get like 4 different terms, and then you just combine like terms, right, to solve for x. So there's my positive 8x. I'm probably going to subtract this one and then add 40. And then I just divide by 7, right? And let's just, for the heck of it, let's check it out. I'm going to drag this down. Put in 6. That's positive. It's greater than 0. That's greater than 0. We're good. That is a solution. We're okay with that. Yes?
So the final solution, the solution, for example, of x equals 6 has to be greater than 0? You have to plug it in.
No, not the solution has to be. We said that this placeholder here in our notes for 2 days in a row, part of understanding logs, that the base has to be greater than 0 and it cannot be 1, and then this has to be greater than 0. And so I'm plugging that back in to make sure it still is. That same thing with this one here. When I put in -1 here, it failed. When I put in -1 here, it failed. So -1 is not a solution. Yes?
So say you only got like one solution, like for that problem you got like 6, and so then like that was your only x value, and you plugged it in and it wouldn't be greater than 0.
Then there's no solutions. Yes, no solutions. Okay, so that was technique number 1. Technique number 2. Pretty logical, like with exponentials. Exponentials was same basis and then different basis. Now it was log on one side, now it's log on both sides. And what we're going to do is very, very similar. In the exponential, my favorite one, the same basis. We got the basis the same, then we just looked at the exponents and dragged it down and solved my math problem. That's what we're going to do here. Same idea. So like there's a problem. Every term, 3 terms, and they all have a log on them. So I would like to get it like my exponential. The base is the same with an exponent. Right now I have a log here with some stuff. I would like to get these two condensed so I have one log here also. So I'm going to work on this side and condense it by using the quotient property. There. So again, since I have an equal sign, and they're both natural log and both base e, doesn't it make sense that this stuff is supposed to match this stuff? And so let's just take it out of there and solve that. Everything already matches. Right?